Hello, I'm Wayne Lack and I'm now doing question 7 of January 2013 Core 3 AQA. And according to my examiner's reports, a lot of people did get full marks on this question and the only mistakes were sort of silly errors. However, that's not because it's an easy question. I think it's actually because it's quite difficult sorts of questions that people practice them so much because they come up time and time again. But most people did do very well. So let's just turn to the whiteboard and go through question 7. Okay, so question 7. There's a part A and a part B and I had no idea how much room it would take up, so I've done them on two separate boards. A curve has equation y equals 4x cos 2x. So part A is find an exact equation to the tangent at the point where x equals pi over 4. So to find an equation to a tangent we need to know the gradient at that point, and so the tangent is going to be in the form y equals mx plus c. We know our x equals pi over 4. We can work out what y equals at that point by putting x equals pi over 4 into this formula. So you're going to get cos of 2 lots of pi over 4, which is the same as cos pi over 2. But either way, if you type that into your calculator, that becomes 0. So the whole expression is going to become 0. So y at that point is 0. And we need m in order to work out our c, our y-intercept for this tangent. To find m, the gradient, at any point on this curve, we need to differentiate this y equals 4x cos 2x, and then we're going to need to put in this x value to find out the gradient at that particular point. So we know what we've got, I'll write it a little bit bigger, is y equals 4x cos 2x, which is in the form u v. So we're going to be using the product rule. So dy by dx is going to equal v du by dx plus u dv by dx. So that's the formula we're going to be using. So first we need to assign u and v to the things in our formula. So we'll say u equals 4x, so therefore v equals cos 2x. As always, we differentiate them with respect to x first, that's the first step. So that's just 4 from our core 1 rules, and dv by dx is our new core 3 stuff. So differentiating cos, you get minus sine, and it's cos 2x, so it's minus 2 sine 2x. And applying our formula, v du dx is that one times that one, which is 4 cos 2x. And it's going to be minus, because of this minus here, although it's plus, u dv dx, which is that one times that one, so it's going to be minus 4x times 2 is minus 8x sine 2x. So that's our formula. And some people actually stopped there because they'd done so many core 3 papers in their revision, they probably thought, well, normally they just ask us to differentiate, I've differentiated it, let's leave it at that. But thinking about what the question actually asks, we need to find a tangent at a point. So we need to find out what m is at that point. So we put our x coordinate into this to get 4 lots of cos 2 pi over 4, which we've already said that comes to 0. We got that up here to get our y value. Minus 8 lots of pi over 4 times sine 2 lots of pi over 4. Now sine of 2 lots of pi over 4, or sine pi over 2, is just 1. So it's going to be 1 times 8 pi over 4 is the same as 2 pi, so it's just going to be minus 2 pi. And you can type that expression into your calculator and you will also get minus 2 pi. So that's our m value up here, minus 2 pi. So now we have y, m and x, we can work out c with our form with y equals mx plus c. So plonking in our numbers we get 0 equals, m is minus 2 pi, x is pi by 4, plus c. So we take that all over this side and expand out the brackets, we get c is equal to 2 pi squared over 4, or pi squared over 2. So now we have the formula y equals minus 2 pi amounts of x plus our pi squared by 2. and it wants an exact equation, so you wouldn't put pi as a decimal, you'd keep it as pi because that's more exact. And you could go on to factorise this, take out the minus 2 pi and times it by x plus pi over 4, or a quarter pi, and that would give you the same thing, or they are the same thing. And so those are your answers, and altogether this was worth 5 marks. Okay, so firstly I had to notice a differentiate, so it doesn't say that, and then differentiating correctly would get you a mark or 2. Then finding out your equation of the line is probably is obviously going to be the rest of your marks, and it's just probably the little bits, like getting that correct is probably a mark, or maybe even 2 marks for 1 correct, then 1 correct. Then plonking in your numbers is probably a mark, then putting it into y equals mx plus c to show you know what you're doing is the mark, and then getting the final answer is probably a mark. So there's 5 marks available here. Let's go on to 7b. Okay, so part B then. The region shaded below is bounded by y equals 4x cos 2x, what we just had, and the x-axis from x equals 0 to x equals pi over 4. So it's shown here, it's shown a quick sketch, and this area is the area that is shaded. By using integration by parts, find the exact area. So it's told us to use integration by parts. We know what points we're integrating between, so let's get on with that. So we're integrating between pi over 4 and 0, this 4x cos 2x with respect to x, and it's told us to do it by integration by parts. So it's of the correct form to do that, so it's quite easy. We need to assign a u, and we need to assign a dv by dx, and then we can apply the formula. I'm put it here. I'm not going to do that. I was going to put the integration as the answer, but that's just silly. I'm just going to put the formula here. uv minus the integral of v du by dx. So just a reminder of the formula. You should know that. That should be in your head, and I believe that one is in your formula booklets, and that's good. But I'll just remember that. So our u is going to be 4x. Our dv dx is going to be cos 2x. So we differentiate this one, just like we did in part A. This gets 4, but this time, rather than differentiating the cos 2x, we've got to integrate it. Now if you integrate cos, you can either know what you get, or you can think, well, what would I have to differentiate to get to cos 2x? The same thing. Now if you differentiate sin x, you get cos x. So if you differentiated sin 2x, you'd get 2 cos x. So we need to put a half in front of here to end up with a 1 in front of here when we differentiate it to get from that to that. Or you could just remember how to integrate from that to that. Either way works. So now we can go ahead and apply the formula. We've got uv to start with, which is that one times that one. So 4x times a half sine 2x. 4 times a half is going to be 4 over 2, which is 2. So it's 2x sine 2x minus the integral of, and then it's v times du dx, which is 4 times a half, so it's 2 sine 2x dx. So this beginning bit's going to stay the same, the 2x sine 2x, but then we're going to have minus, and what's the integral of this? So we know it's going to be cos, but is it going to be minus cos? Well, think about it. If you were to differentiate cos, you get minus sine, but we want to end up with positive sine, so it must be minus cos 2x. And you could check that by differentiating that. You'd get 2 sine 2x. Now this minus minus, we can just change that for a plus. Obviously in your actual exam, you just write on the line below plus. Or you could, if you're really good, you could just have skipped that step and known it was going to be a plus. But I was just showing it's minus, and that turns into a minus, and that's what makes it a plus. Now we do what we always do with integration. We put in our 2 values, so we have 2 lots of, firstly, all the x's are changed with pi by 4, sine 2 lots of pi by 4, plus cos 2 lots of pi by 4. Minus, and then all the x's are changed with 0. So if this is 0, 2 times 0 is 0, so it doesn't matter what sign comes to, it comes to 0. So on this side I've just got cos, and 2 times 0 is going to be 0 anyway, so I'll just go ahead and put that in. So, what are these things? Well, we've already done cos 2 lots of pi over 4 twice now. We did it in A twice to find out what y equals, and we did it when we were finding out what m equals. That comes to 0, so that part just disappears. Now, sine of 2 lots of pi over 4 becomes, again, as we've already done it in part A, just becomes 1, that is just 1. So it's 1 times 2 pi over 4, which becomes pi over 2. Minus cos 0 is 1, you should know that either from the graph like I do, or you could type it into your calculator, either way is fine. And again, in the question, where is it, an exact area. So don't put 3.14 in place of pi, make sure you put pi. Again, part B was worth 5 marks. Despite telling you what integration to do, you'd still have got a mark for applying the correct formula. You get a mark for this, selecting all of your things. You probably get a mark for integrating that correctly. A mark for that, a mark for that, a mark for the answer, whatever. And things that people tripped up on. Most people selected the correct formula because it tells you to. Very few people didn't do that. Most people got this bit fine. Some people didn't do the minus minus to make it plus. You've got to be careful because the formula says minus the integral of this. So just be careful of that, it's not plus. So minus minus is a plus. And then a few people made arithmetic mistakes here or typed it into their calculator wrong. You just got to make sure that you type it in correct, double check it with perhaps more than one calculator or the same calculator more than once. You get your final answer like this. It didn't mention anything about no one putting 3.14. It didn't say that anyone accidentally did that, but I just thought I'd mention because it says exact. Just make sure you do keep it in terms of pi, no decimals. I hope this helped at least a little bit for question 7, and I'll see you at question 8.